recirculating systems are environmentally friendly, but they are also expensive, complex, and labor-intensive. The design for such systems will vary, but will contain essentially the same key components. A main grow-out tank to contain the fish, a solid settling filter to remove sediment, a biological filter for removing nitrogen, an air blower for aerating the water, a water pump to circulate the water through the system, and appropriate plumbing connections for water transfer, waste disposal, and drainage. The growing tank can be as simple and cheap as a backyard swimming pool or more durable, such as a concrete or molded plastic tank. The lifespan should be taken into account when selecting a tank. For instance, a backyard pool may only last 2 or 3 years, while a concrete tank may last 15 years or more. The size of the growing tank will determine the number of fish you can raise. For tilapia, you will need at least 4 gallons of water per pound of fish.
The minimum shape and size of a tank is really dependent on how much fish you want to produce. You can go with as small a tank as a 5-foot diameter tank or up to 30 feet or more. The minimum depth is more important. It should be above 2.5 feet or deeper than 2.5 feet, simply to prevent the water from overheating because of the intense heat we have out here. There is a preferred shape. The round tanks seem to be preferred simply because they have a maintenance-free design to them. When you circulate water in a circular pattern, it tends to draw the solids towards the center, as you would if you were stirring a glass of iced tea.
Maintaining good water quality is critical to success. It provides a healthy environment required for rapid fish growth. Fish wastes and uneaten feed result in higher levels of ammonia and other nitrogen compounds that are toxic to fish. These toxic wastes must be converted to safer forms or removed from the system. Uneaten feed and fish wastes affect water quality in 2 ways. Solids can accumulate and create anaerobic conditions that will produce gases that are harmful to fish. As solids break down, they release ammonia, which is also toxic to fish. To maintain water quality, it is necessary to pass the water through a filtration system. These systems can vary in both cost and complexity. The filtration system will have 2 parts, a solids removal component and a biological filter. Properly designed tanks accumulate solids in a drain area where they are easily removed. Circular tanks, or tanks that create circular water motion, accumulate solids more efficiently by moving them to the center of the tank. The accumulated solids are transferred to a settling tank by means of a siphon or through bottom drains. Solids are thus allowed to settle out. The water then passes through netting, plant roots, or other media to trap smaller solid particles. A water pump is used to circulate water from the holding tank through the filtration system and back to the holding tank. The toxic chemical contaminants are removed through a biological filter. This filter is usually placed after the solids filter, or it may be an independent, standalone system. The biological filter utilizes bacteria to convert ammonia to nitrite, then nitrate, which is the form of nitrogen least toxic to fish and preferred by plants. The efficiency of the biological filter is dependent on the population of bacteria. This is a function of the surface area available for the bacteria to grow on.
You really need to concentrate on design for a maintenance-free, easy way to remove solids. The circular tanks with the flow drawing the solids to the center is one of the easier ways. On the nitrification or the conversion of ammonia to nitrate, it's a matter of what you have on hand and what's economical, but basically you need to have material that bacteria can grow on.
A general rule for warm water aquaculture is to have 300 square feet of filter media surface area for every pound of feed per day. Plants can also be used as a biological filter to remove the nitrogen compounds. Using plants to maintain the water quality in the system will require water testing and fine-tuning as you go along. Like most living things, fish need oxygen to live. Even though tilapia can tolerate lower oxygen levels than many other species, it is critical to maintain sufficient oxygen levels in the water, particularly in heavily stocked tanks. The ideal dissolved oxygen level for tilapia is 5 parts per million. Heavily stocked tanks are more susceptible to oxygen depletion and so require close monitoring of oxygen levels. One of the simplest methods of providing oxygen is the use of a diaphragm air pump or rotary air blower. The pump forces air through air stones or diffusers, creating tiny bubbles which allow more oxygen to diffuse into the water.
There are basically 2 air pump types used by the backyard aquaculturists. One is the diaphragm air pump, the other is the rotary air blower. The diaphragm air pump is simply a small or an enlarged version of an aquarium pump that operates off a rubber diaphragm. It'll give you a fair amount of air and a higher pressure than the rotary air blower. The air blower provides you a lot more air at a low pressure. The costs are about the same for the power rating of the pump. Most backyard farmers will use the rotary air blower simply because of the volume of air that it can give you.
Other physical components for the recirculating system are the pipes and fittings that will be needed to connect the pump, filters, holding tank, and aeration system. Another component to consider is the spill pipe or some method to drain the system. Since the recirculating system is dependent upon electrical devices such as the water pump and air pump, providing backup power is strongly recommended to avoid disaster. A ground fault circuit interrupter is highly recommended to avoid electrical shock and injury.
When selecting components for your operating system, you need to think about 2 aspects of the cost beyond their initial purchase cost. First thing you need to consider is how the component will affect your regular maintenance activities. For example, in the filters, you can buy an expensive filter that may only take 10 minutes a day to clean and maintain, versus you could buy a cheap filter that may take 20 to 30 minutes a day. In the end, you'll save money by buying the more expensive filter. The other aspect you need to consider is the cost of the component when compared to its life. A concrete tank like this one may cost you $1,500 up front, but it's going to last for 15 to 20 years. That's going to come to, when you look at it in terms of an annual cost, between $75 to $100 a year. Now, that's versus a backyard swimming pool like this one, which is going to only cost you $500 up front to purchase and set up, but it's going to have to be replaced after 3 or 4 years. Now, that's going to come to $125 to $165 annual cost. In the end, the concrete tank is more durable, and it's going to be a whole lot less cost and a lot less trouble.